Hello friends, it's your NOLA Mathman here again for another math adventure. Unlike Superman, I cannot leap tall buildings in a single bound, and I'm not faster than a speeding bullet. But in regards to math,
Superman got nothing on me.
After this video, students will be able to solve angles and angle measures in regards to right triangles. The concept we're looking at is trigonometry or trigonometric functions. The skill we're learning is how to evaluate angles and angle measures within the right triangles. So with no further ado, let's get started with lesson 12.2. So in our first problem, we're going to learn how to draw an angle from a given measure in standard position. Now we're not dealing with right triangles. We're looking at an XY coordinate plane, just draw an angle so you can get familiar with the 360 degrees in a coordinate system. So the first thing I do is we label our axis according to their appropriate degrees. The X is what I'll call the X positive is 0 degrees. The Y positive is 90 degrees. The 270 is the Y negative. And so what I did here is the NOLA Mathman drew 185 degrees. It's right below or a little past 180 degrees. So you draw what we call the side, the reference side, terminal side is 0 degrees. So again, there are vehicles to help you draw it accurately. You can use a protractor. That makes it easier to measure it out like the NOLA Mathman did. So now we're going to do 810 degrees. Now if you label, like we did the last coordinate, from 0 to 360 degrees, we know this problem will have to rotate more than once because 810 degrees is way greater than 360 degrees. So what you want to do is you want to label each group of 90 because it's 90 degrees between each axis. And so that's what I rotate. 0, 90, 270, back to 360, then you put 450 degrees. You're just adding 90 degrees for each part of the axis. 540, we have 630. So we're gonna keep labeling it till we get around 810. So we have 720, and if we add another 810. So it's right there on the y-axis, but it's the third rotation. So we go once, you have to indicate that. We go twice, going counterclockwise, and we stop at 810 degrees. And so that's how you would draw the angle from its standard position. We have a total of 3 rotations. So that's number 2. And that's a different type right there. So let's see what we're gonna do next. What's the NOLA Mathman gonna do? We're gonna draw another angle. What kind of angle have we done? Maybe we should do a negative angle, I don't know. Oh, here comes one right here. We're gonna draw negative 50 degrees. Now, positive is what we call counterclockwise. Negative is actually clockwise. So we're gonna go in the opposite direction to indicate the negative degrees on the XY coordinate plane. So again, so what we will do, we label, is our terminal side will be the positive x-axis. That's still 0 degrees. But we will now rotate clockwise, and our negative y will be negative 90 degrees, which should pop up here in a second. So we draw what we call our terminal side. And now we're going to draw the other angle that's created when you combine it with the terminal side. So we're going to hopefully label, because that is 0 degrees, that doesn't change. But as you can see in a sec, it's taken the NOLA Mathman a minute to label his axis. Maybe he's getting confused with the negative angle. Just freaking it out. So let's see what we do here. We're waiting, and so we have negative 50 degrees here. Oh, okay, so it took him a while to use the protractor, and so he wanted to draw, as you can see, that's a very accurate line. He probably used a good protractor there. And what we should have did, you see it goes in the clockwise direction, and negative 50 is like, yeah, see, there we go. We labeled that negative y-axis, negative 90. Negative 50 is a little more than halfway rotation between 0 and negative 90. And so we draw a line that represents the measure. Very good. So we did a negative theta there. What are we going to do next here? Do you think the NOLA Mathman is going to try now? So we're done with number 5. And we're going to pop up another problem here maybe. Maybe we'll do a different type of problem next. Yes, so we get rid of that. We're going to bring up another type of problem to do. Let's see what's next. We're going to find an angle with a positive measure and an angle with a negative measure that are coterminal with each angle. Coterminal, what does that mean? We're going to find out, see what coterminal is. So I'm sure some problems will pop up here in a second. So let's see. We have a group of problems that we're given certain angles. We have 7 through 10 here. We're given different angles, and we will find the positive measure and angle with a measure, negative measure, that are coterminal with one another. So we have here 45 degrees. That's what we have first. Now, to find coterminal, we mean in the same spot given a number of rotations. It could be 1, 2, 3, 4 rotations. So for instance, we know we rotate one time, it'll be in the same place. That represents 360 degrees. So to find a positive coterminal, we will add 360 to 45, we get 405, and we subtract 360 and we get negative 315 degrees. So now we're going to do number 10 where we have a negative 90 degrees. And again, we want to add or subtract by a multiple of 360. So we can add 360 degrees and negative 90 degrees. We get a coterminal of 270 degrees. We're going to take negative 90 and we're going to subtract 360 degrees. And that will give us a negative value, which is negative 450 degrees, which we want. And so we have two negative and a positive measure that is coterminal to the given angle. So let's see if we're going to do another one here. So we've done one that had a positive theta. We did another one with a negative theta. So let's see what we do now. Oh, so now they're giving us angles. You can measure angles in two ways. This is the first problem that kind of gets into that concept. You can measure angle with degrees, or you can measure angle with radian using radian. So this is, all these examples are radian measures that are given. And so we're going to do one of those. Now, instead of adding by 360 and subtracting, when you deal with theta, the one rotation is what we call 2 pi. So that is like the 360 for degrees. So we have 2 pi over 3. To create a positive, we're going to add 2 pi. And so we have to get the denominators to be the same. So we put 2 pi over 3. We have to take 2 pi into a fraction over 3. That's 6 pi over 3. We add the numerators. And so our positive coterminal will be 8 pi over 3. Now, for the negative, we will subtract 2 pi from 2 pi over 3. Again, we get the least common denominators, 3. We're going to subtract 6 pi over 3. 2 pi minus 6 pi is negative 4 pi over 3. And so again, we have a negative radian measure that is coterminal. And so that's our two answers. So we did a positive radian measure. I think we'll probably now do a negative radian measure next. So now we have 14. We have negative 3 pi over 4. So now if we want a positive one, we're going to add 2 pi, because again, that equals 1 rotation in terms of radian around a circle. And we will put 3 pi over 4 plus, we have to get the least common denominator of 4. That will be a pi over 4. We add the numerators, and so our final answer will be 5 pi over 4. That's the positive radian measure. To get negative, we will subtract 2 pi. Again, we will get the least common denominator of 4. Negative 3 pi over 4 minus 8 pi over 4. We add the two negatives in the numerator. That will be negative 11 pi over 4, and that will be our answer. Very good. So we're done with that. Is everybody, understanding? So good. Looks like we're understanding. The more you do, the easier it becomes. So let's see if we're going to do any more problems like that, or we go to another concept. Okay. We're moving these out the way, so it looks like we're going to do another type of problem next. See what we do now. Rewrite each degree measure in radian and each radian measure in degree. I just told you there are two ways of expressing it. These problems will look at what I was just talking about. So here we have degrees, so we have to change each of these into radian measure. And so we'll pick one of those. Which one do you think the NOLA Mathman is going to do? Let's see, I don't know. Oh, 15. So we have 130 degrees. We want to change it into its equivalent radian measure. So when you convert radian, degrees of radian, you have to know that pi radian is equal to 180 degrees. So we call unit multiplying. We're going to put the degrees in the denominator, cancel them out. We're going to put pi radian in the numerator. And so now by doing that, we will convert. And you divide both sides by 10. And so you end up with 13 pi over 18 radian. And we have now converted it. Very simple concept. Again, the more you do this unit, we call it unit multiplying in science. You do that when you convert liters to milliliters and stuff like that. Same concept, same principle. So now we're going to do number 20. We have a negative degree measure. And again, we will use the same, what we call unit multiplier. We're going to convert 180 degrees to pi radian, like we did before. Since we're trying to eliminate the degrees, we put the degrees, 180 degrees in the denominator. We put pi radian in the numerator. We factor out the degrees. We divide both by 10. We divide 18 and 27 by 9. And we will end up with negative 3 pi over 2 radian. And that will be our answer. Pretty simple. Very good. Looks like everybody's getting it. So we did a positive degree measure. We did a negative degree measure. So now, we're now going to go the reverse. We're going to now go from radians to degrees. So I assume that's what the next group of problems will entail. There we go. So now we have a bunch of radian measures that we want to convert into the equivalent degrees. So let's see which one of these 6 the NOLA Mathman will do. Oh, we'll start with number 21, pi over 3 radian. And again, we're going to use the same unit multiplier, 180 degrees equals pi radian. But this time, we will put the radian in the denominator and we'll put the degrees in the numerator when we multiply to eliminate the radian. So you will see that 180 degrees numerator, pi radian in the denominator, the radians factor out, the pi's factor out, 3 goes to 180 60 times, and so you will end up getting 60 degrees as your final answer. And again, the more you do it, the more it becomes easier, the more comfortable you will be with this process of conversion, but it's pretty simple. So let's try another example. This time we're going to do 5 pi over 4. We want to convert that into its equivalent degrees. Again, pi radian is 180 degrees. We want to put pi radian in the denominator, put 180 degrees in the numerator, which will pop up in a sec. We factor out the radian, we factor out pi, we simplify as much as possible. Looks like 4 goes to 180 equally. That's 45. 45 times 5, which is left in the numerator, will give us 225 degrees, which is the answer. Again, we circle our answers like we've been taught to do. We want to be consistent with the process. So, we've done that. Let's try a negative, looks like. I think we've done 2 positive radian values. Let's try a negative radian value. So we have negative 3 pi over 4. Again, we use pi radian equal 180 degrees. We go negative 3 pi over 4. We put pi radian in the denominator. We put 180 degrees in the numerator. We factor out the radian. We factor out pi. We divide both sides. Looks like 4 goes to 180 equally. I think we just did that. I think it's 45 times. And then we multiply 45 times negative 3. And that's how many degrees we should end up getting for our final answer. And that answer is what? Get your calculators out. You can do it on your paper. And that will get us a value of negative 135 degrees. And again, we circle our final answer. And so we're done with that. Is there anything else we can do? Are we done there? Let's see. Well, it looks like, yeah, we got 26. We're going to do another negative one. Do 2 positive ones, 2 negative ones. Negative 7 pi over 6. Again, we should know the conversion by now, like the back of our hand. 180 degrees. Pi radian equal 180 degrees. You put negative 7 pi over 6 radian. Multiply by the unit multiplier, pi radians in the denominator, 180 degrees in the numerator. Factor out the radian, factor out the pi. 6 goes to 180, 30. 30 times negative 7 gives me negative 210 degrees. And that should be our final answer here, which again is going to pop up here on our screen. There we go. Negative 210 degrees. So we have done that. Let's see, are we done now? Where are we at? We've done a variety of different problems here. And so looks like we're done with another math adventure. The NOLA Mathman has helped us conquer our math fears. And so until we meet again for another math adventure, this is the NOLA Mathman signing off. Have a blessed and prosperous day.